Okay, so we're doing day 3 of slope of a tangent, and I want to start by just reviewing a little bit about what we've done so far. So let me just go back to the not that one. Here's what we've done. So in the last lesson, we talked a little bit about why this works. I'm not going to get into those details again, but we looked at an example. This is a polynomial that we did, right? And so that's one of the 3 types. And here was a polynomial. We were given the x value, and we solved for the slope of the tangent. This one is a fraction or a rational function. Okay, and so the point here is the strategy is different for each of them, or the technique that we use is different for each of them. Right? With the polynomial, you're just factoring. With the fractions, you're doing some work to clear out the denominator. And then the third type that we've seen is the square root type, and you multiply by a conjugate for this. That's a strategy for this one, right? So we've got 3 strategies, we've got 3 different types of questions, and that's a very focused summary of what we've done so far and sort of the skills that are required for the work that we're doing in this unit. Okay, and so that really summarizes the main skills that are needed for this unit, right? We've got these 3 types. If you're taking calculus, there's a 4th, but we don't do it in this course, so we'll get to that. When we start calculus in a couple of weeks. Otherwise, those are the 3 skills. So it's really so useful, as I've said so many times before, that you understand how to identify a type of question, and you understand that, oh, it's this type of question, and so I do this specific procedure, and it's a very repetitive kind of process where we're doing the same thing every time once we identify what type of question we have, whether it's polynomial or fraction or square root. Okay, so those are the 3 types. What's going to be a little bit different in this one is that we'll recognize right away that this question is a polynomial. Okay, it's just quadratic. But instead of giving us the x value or the point, it's giving us the slope of the tangent. So these questions are different, obviously, and the way we set them up is a little bit different. It has something to do. The other thing we did that I didn't mention is coming up with an expression for the difference quotient or the slope of the tangent, as opposed to actually solving for the slope of the tangent at a particular point. And so that's going to be similar to what we're going to do for how to solve these questions. So for these ones, we're not given the x value, and we don't get to sub in at first. We have to kind of do the slightly more challenging algebra, and then we're going to sub in for the slope or for the actual slope of the tangent that we're given at the end, and solve to find the point. Okay, so that's kind of what today is about. It does look a little bit different, but the strategies, those 3 strategies of the 3 different types of questions that we've looked at, that all is the same. Okay, that's not changing. All right, so let's take a look. So we're going to start with the same thing. Slope of the tangent is equal to the limit as x approaches a of f at x. This is just the formula. Now, here's something that we have to remember when we're doing this, like with just the expression and not with an actual value. F at x is 2x squared plus 5. That's just the function. So what's f at a? Well, it's 2a squared plus 5, right? So this is going to be 2x squared plus 5 minus bracket. Be careful of that. That's a really simple mistake. That would make everything not work at all. Again, there is a little bit of that danger in these questions that even the smallest mistake in a negative will make you not be able to finish these questions. They have to work out a particular way. Things have to cancel out. And so if you make any kind of small computational mistake, then they're not going to cancel out, and that's going to be a major problem. So there's not much we can do about that except for be aware of that potential danger. Okay, so just going to expand this out. And that's the key, that the positive 5 and the negative 5, if I didn't have brackets around the 2a squared plus 5, and then it would be 5 plus 5, which is 10, and they wouldn't add to 0, and that would cause the problem. So now I've got 2x squared minus 2a squared over x minus a. So here we're going to common factor, and this is the technique for polynomials. Often we're going to do a common factor first, and then in this case it's going to end up being a difference of squares. In other cases it might be a different kind of factoring, but the idea is that you are factoring at some point, and that's the technique. And like I've said, it becomes familiar. We get to a point where, you know, we sort of, we've been through this before. We expect what's going to happen. That's kind of where we want to be. And this is the thing that has to happen again, that you've this x minus a. Again, if you look back or you think back to what we did in all those demonstrations, as x approaches a, when x actually is a, it ends up being x minus x, which is 0, and you can't divide by 0, so that's a problem. And so we have to get that x minus a factor divided out, and there we have it. That's what has to happen. You get to the end, you get to this step, and that doesn't happen for some reason. You've factored and it's not, there is no x minus a factor. Well, then that means you've made some kind of mistake, some kind of calculation error. You set something up wrong, because that has to happen. So now we have 2 times x plus a. Okay, so that's sort of our first step that we're working towards, is getting the x minus a factor to divide out. Now is where we can plug in, and I know that this is a bit confusing, subbing in a for x or x for a or whatever, like the x's and the a's, it kind of becomes confusing. But again, just practice this a few times to make sure that you get how this works. So we are subbing in a. Usually it would be something like the limit as x approaches 2 of, let's say, x squared plus 3, and we would sub the 2 in for x. So in this case, we're subbing the a in for x, so we get 2 times a plus a. A plus a is 2a. Whoops, getting ahead of myself. So that's 4a, and that's the slope of the tangent. That is an expression for the slope of the tangent for this function, 2x squared plus 5. At any, and this is where, again, it's a little bit confusing. Now we've got an a in there, but a kind of represents your x value. So whatever x value you wanted to sub in, that would give you the slope of the tangent at that point. But in this case, we're not given the point, we're given the tangent. So at slope of the tangent equal to 8, we get 8 is equal to 4a. Obviously divide both sides by 4, and we get a equals 2. Okay, so that's our x value, where the slope of the tangent will be equal to 8. And but it asks for the point. Sometimes it might ask for the x value. It might just ask for the location. Sometimes it asks for the point. This one does ask for the point. So that means we have to do f at 2 to find the y value. And 2 squared is 4 times 2 is 8 plus 5 is 13. Therefore, the slope of the tangent is equal to 8 at the point 2, 13 for this function. Okay, and if we graph this, you know, it's a fairly simple graph. It's got a shift up and then a bit of a stretch. You know, we would be able to visualize that fairly easily. Okay, so that's the idea, is we're doing this algebra work, which is a little bit trickier than when you're given the x value, but that's kind of the idea. And we come up with this expression, and then instead of subbing in for a, we sub in for slope of the tangent. Okay. Otherwise, it's all the same. Whether you are, like, the strategy is the same, whether you're doing polynomial or the fraction, the rational function, or you're doing a square root function, it ends up being the same. Okay. Now, some of these questions, like we'll see here, I don't know why this is called example 1. I guess the first one wasn't labeled at all. So for this one, sometimes we refer to these as a little bit of problem solving, and that's because they don't necessarily give you all the information directly. So this one says determine the point or points on the curve. Obviously, that means there may be more than one, which when you think about this kind of a rational function, which would look something like this, you're going to have 2 places where the slopes are parallel, right? That's a pretty terrible drawing, but anyway, you get the idea. And so for this one, there's probably going to be more than one where the tangent, but it says where the tangent line is parallel to this line. So what does it mean when it says parallel to that line? Well, you just have to do a little bit of problem solving, a little bit of thinking, and recognize that the slope of this line is 5 over 9, y equals mx plus b, so that's your slope. So the slope parallel to that, that's not an 11, that's the parallel symbol, is the same. What if it said it was perpendicular? Well, then that's something that I'll leave it to you to try to remember from grade 9, what it means when slopes are perpendicular. This is going to be a huge thing in this unit, but then also in calculus, if you're taking calculus, where we talk about parallel slopes or perpendicular slopes. So this is kind of an important thing to figure out. If you're not sure what that means, of course, you're always welcome to ask, but I'm going to kind of leave it to you. I don't think it comes up in this lesson. But it will come up in the homework or possibly on a test or something like that. And it certainly will come up in calculus. So leave it to you to just think about and try to remember what it means if 2 slopes or 2 lines are perpendicular to each other, what that means about their slopes. Okay. And therefore the slope of the tangent is 5 over 9. Now you do not need to write this out 3 times. You can just say the slope of the tangent is 5 over 9. You should make that statement. Definitely somewhere, but that's the idea. The slope of this line that we're parallel to is 5 over 9. A parallel slope is also 5 over 9, which means the slope of the tangent is 5 over 9. Okay. All right. So let's get into it. Slope of the tangent. Again, is limit as x approaches a of f at x minus f at a, for x minus a. And so the limit as x approaches a of 3x minus 1 over 2 minus x minus 3a minus 1 over 2 minus a over x minus a. Again, f at x is 3x minus 1 over 2 minus x. So f at a is 3a minus 1 over 2 minus a. Now is where we choose our strategy. So in this case, we're going to multiply by a common denominator. So 2 minus x over 2 minus a over 2 minus x, 2 minus a. So I'm multiplying by a common denominator in the numerator of the limit statement. Again, there is another way of doing this. You can get a common denominator on top, right? So there's two slightly different ways of doing this kind of a question. And you just pick your favorite, okay? There's a whole bunch of work that happens here, so I often come off to the side, show the work, and then come back. This is just a good way to organize your sort of space on your page. And some of this you might be able to streamline and do a little bit more quickly. So, oh, and I'm only showing the top. This is kind of the point, and I'm not going to write the limit statement every time. Really what I'm doing is I'm just figuring out what that works out to. That's kind of what's happening here. So I got 3x minus 1 times 2 minus x times 2 minus a over 2 minus x, right? And minus 3a minus 1 times 2 minus x times 2 minus a over 2 minus a. Okay, so those divide out and those divide out. And then there's a whole bunch more work that we can do here. 3x minus 1, 2 minus a, minus 3a minus 1, 2 minus x. And I mean, we can go back and do this in the actual original question, but again, like rewriting the limit statement every time over x minus a, I guess we're just kind of being lazy here. So we're just going to expand. 3x times 2 is 6x minus 3xa minus 2 and plus a. Let's put that in brackets to be careful here. So 6a and then minus 3ax minus 2 plus x. And we get a whole bunch of things here that add to 0. So negative 3xa and positive 3xa. We've got a negative 2 and a positive 2. And we end up with 6x minus x, which is 5x. And negative 6a plus a, which is negative 5a. Okay? And that's kind of where we now have to go back into our limit statement. And now we do a final factor. So this is a common mistake that I almost made here, where we forget about the fact that this was multiplied by the denominator there as well. So I've got to squeeze that in. So this is x minus a. And, you know, I often find that, I don't know, if you're rushing through a question and you make that mistake, you get to the end and you realize this would divide out and you'd get 5, and that doesn't really make any sense. So then you kind of go back and say, whoa, I'm missing something here. And this should actually be x minus a, 2 minus x, 2 minus a. So those do divide, but you should get some kind of expression here, not just a constant. Okay. Again, I've said this before, I want you to write out this final step. I don't want you to go to sub in yet. You got to show that step. Okay. And then we can sub a in for x. And that's where you drop the limit notation. So you gotta show me this step before subbing in for A. I know it seems a little bit like rewriting, but this is really important that this expression in that whole final line is fully simplified with the x minus a part divided out. Okay, then show the substitution step, and then usually it's not a lot of work anyway, but even if it is a bit of work, you can go straight to the answer. I don't care how many steps you use to get to that answer, but you should have those 3 steps, not skipping any of those. Okay. All right, now back to the start. We were given the slope of the tangent. It was parallel to a particular line, but we used that to determine that the slope of the tangent is 5/9. So that's what this is our slope of the tangent, right? Our expression. So when slope of the tangent equals 5/9, so we get 5/9 equals 5/2 minus a all squared. Now, it's funny how at this point, actually, some people get very confused about what to do moving forward. And this is just fraction math, and this is just kind of solving. I guess maybe I'll do it sort of slowly. Like if I divide both sides by 5, these 5s divide out. But what you're really doing is multiplying through by both denominators to clear the denominators. So you end up with 5 times 2 minus a all squared and 5 times 9. And now we can see if we divide both sides by 5, the 5s divide out. And we're left with 2 minus a squared equals 9. So we're going to take the square root of both sides. You could multiply this out, 2 minus a times 2 minus a, and do that whole thing, and you get a quadratic, and then you'd have to solve that. But the easier way is to take the square root of both sides. And of course, when we take the square root, we get plus minus. So we get 2 minus a equals -3, and 2 minus a equals +3. And remember, we talked about this in the very beginning of this example, how we were sort of expecting there to be 2. And this is where fundamentally, back to the very beginning of this course, when we talked about how our understanding of functions in general helps us with the algebra and helps us make sense of answers. When you're doing a question like this, when you're doing a rational expression, you could probably expect for there to be 2 answers because of how that function looks. And so if you got to the end and you only have 1 answer, that might be an opportunity for you to catch yourself and say, hold on, shouldn't there be 2? And then you'll remember it's probably because you missed the plus minus, right? So I get -a equals, subtracting 2 from both sides is -5, so a is 5. And -a, again, subtracting 2 from both sides is 1. So a equals -1. And again, it asked for the point, not just the x value or the location. So f at 5. And at this point, you really don't need to show all of the substitution. You can just do it on your calculator and get the answer. But it works out to -14/3 for this one. But again, this happens a little bit in this unit, but more in calculus. But people start to get really confused about what they're subbing back into. So this is when we get these x values, which I know it says a equals, but it's actually the x value, right? The location. We're subbing back into the original function. And later on in calculus, really, but you're going to have so many different functions that you're going to be subbing back into that you're going to have to remember, wait, which function am I actually subbing back into? Is it the original one or one of the other functions that are involved in the question, right? So it's something to be aware of, something to think about. So therefore, we've got 5 and -14/3 as one of the points, and the other point is -1 and -4/3. Okay? So that's a general idea. We're going to do one more, and we're going to do the third type of function that we've been looking at, which is a square root function, and see what this looks like. But it's the same thing, right? It's still just we're going to use the multiplying by a conjugate strategy and sub in for slope of the tangent, which in this case we're given. It's just 2/3. And so we'll see what the algebra looks like, but it's the same kind of process. Okay, so Slope of the tangent is, again, just writing out the formula. So f at a is the square root of 4a minus 1, right? So we've got root 4x minus 1 minus root 4a minus 1 over x minus a. Strategy is conjugate, so 4x minus 1 plus 4a minus 1. And of course we have to multiply by 1, so it's over the same thing. And we talked about this before. You can look back at that other video to see the sort of longer version, but you know, the whole point of a conjugate is we know how it's going to work out. So this ends up being 4x minus 1 minus 4a minus 1. And this is that same common mistake that people make, is they forget to actually include the denominator. Very similar to what we just talked about. Okay, so it should look like that. Plus 1. So there's your negative 1 and your plus 1 are going to add to 0. And that has to happen. So I'm going to common factor this right now. 4x minus a okay, and there's the whole point, divides out. And again, if we forgot the conjugate part of the denominator, we'd have a constant of 4, and hopefully we'd recognize that that doesn't make any sense. This is the step that you have to write out. Then one step to show the substitution. Got two of the same bracket. So I can write this as 2 bracket 4a minus 1. And in this case, 4 over 2, that simplifies, so I can take one more step. And if you had done those in the same step, like I said before, that's kind of okay. And so there we go. So our slope of the tangent is 2 over 3. So we've got 2 over 3 equals 2 over root 4a minus 1. Again, this is where I can divide both sides by 2 and then do what people love to call cross multiplying. And but you're multiplying out to clear the denominator, so we get square root of 4a minus 1 equals 3. This is different from the other one where we're not taking the square root of both sides, we're squaring both sides. So there's no plus minus. Add 1 to both sides and divide by 4 and reduce, and we get a is 5 over 2. Okay, and just very quickly, f at 5 over 2. So that ends up being 2 times 5, which is 10, minus 1, which is 9. So that's 3. So our point is 5 over 2 and 3. And again, we were asked for the point, so just make sure that you're careful what the question is asking for. This one says points of tangency, but there's only one. And if we think about a square root function, you would expect there to only be one. Why would you have two? I mean, the square root function, this one obviously has some transformations, but the base square root function looks like that. You're not going to have 2 points of tangency, right? You're going to only have one. So just the fact that it has that s in brackets does not necessarily mean that you're going to have 2. Probably every question is going to kind of say that. And in some cases you will, and in some cases you won't. Okay. Okay, we've still got one more. But I'm going to leave this question to you to think about and figure out. It's just a polynomial, so we've already seen this type. It's not different, but it's asking us to determine the vertex. So this is something that you may have done in a couple of different ways, starting back in grade 10, where we're determining the vertex of a function. And in grade 10, you learn how to complete the square. There's a couple of different ways that you can do it, right? But you know, the main way you probably did it was by completing the square. So now, as we are completing this course and moving into calculus, we're going to, this is like a huge important part of calculus, is how do we use this idea of slopes of tangents to determine a vertex or a turning point. This is something that we're really going to get into. So I'm going to leave it to you to think about. I will complete the solution to this and include it online. I may not do that right away. I want you to really think about it and see if you can figure it out. It's not that big of an idea, but I want to give you a chance to think about it because, like I say, it's a pretty pivotal idea in calculus. It's kind of what calculus is all about, okay? So think about that, but there's no new math. There's just a small insight that's required for this, and otherwise that is the lesson for today. Again, just pointing out that we've talked about the 3 different strategies for polynomials, rational functions, and square root functions, and what the particular strategy is for each of those, getting familiar with what the algebra looks like, with what the steps look like, and then understanding that in this case, what we're actually doing is we're given the slope and we're finding the location, the x value, or the point, which means find the x value and the y value. Okay, and that's kind of what this lesson is all about, if you wanted to summarize it briefly like that.